And coming up next on this hour and a half, we've got Colin Wright. So Colin is a pure mathematician and does a lot of talks about why maths is exciting, why people should be inspired by it as well. So I'm looking forward to having a little chat with him to see what he says, why he thinks people should be inspired by maths. So if I could ask Colin to turn on his video and unmute.
So that should be me.
That's brilliant. So can hear you a little bit quiet, Colin.
A little bit quiet. I'm not sure I can change that.
Just a little bit to me.
How's that now?
That is much better. I can hear you a little bit clearer there.
Basically, I just need to project and possibly need to talk into the microphone.
That'll be the one. That'll be the one. I've learned that myself this morning.
Yep.
Well, welcome. It's so nice to have you. Do you want to tell us a little bit about what you do when you're not here speaking to me?
Well, basically, up until earlier this year, I'm a freelance torturer of adults and confuser of children. So I go out and I do talks and presentations on all aspects of maths. I'm possibly best known for a talk on the mathematics of juggling. So way back in the 1980s, some friends of mine and I devised a notation for juggling. And via that notation, we discovered new juggling tricks that had never been done before. So there were unexpected patterns, unexpected things going on, unexpected connections between juggling tricks, which in the 2 millennia of juggling, 3-4 millennia of juggling, people hadn't found that this juggling trick was actually similar to that one. And we discovered that and then found a whole pile of new juggling tricks beyond that.
That's amazing. How did that feel, that moment when you realized that maths had taken you to new juggling tricks?
It dawned slowly because we kind of thought, oh, this will work and this will work. And then suddenly we thought, hang on a minute, we've got dozens, perhaps hundreds of these that nobody has ever done before. And it's just an amazing feeling. And that's the thing about maths is when you're doing research in maths, and sometimes actually when you're in school and solving maths problems, it's just like banging your head against a brick wall. Nothing happens.
Yeah.
And then it all falls into place. If you're lucky, or if you work hard, or if you happen across it. And the feeling is just amazing. It's absolutely amazing. I don't know anything like it. So it's a great thing to happen. And so I try and share that with other people when I go out. And I started by going out doing talks about juggling because that's what people knew. And then people liked it and wanted me to come back, but they'd already seen the juggling talk. Mm-hmm. So now I have a portfolio of about 20 or 30 different talks that I can do. Occasionally I am mathematician in residence at a school, and I'll do a series of 25 talks to all of the cohort, ranging from year 6 coming into the school all the way through to year 13, maths, further maths, physics, and sometimes for the entire school, because some of the work that I do, some of the talks that I do are genuinely available to a general audience.
That's fantastic. A mathematician in residence, very cool title, and sounds like a really amazing opportunity to get to work with one school as well.
It's fabulous. It really is.
Brilliant. So what have you got lined up for us?
Right. Well, let me unmute my camera, and because I love
the phrase unmute a camera.
So you should now actually also have another camera, another Zoom attendee, which is my camera.
Yes. Yeah, right. We can see a table with some pens and cards.
Okay, so if you switch to the table, this isn't a magic trick as such, although it does involve playing cards. These are my Princess Diary playing cards. We happened to go to a stately home, which was where some of that was filmed. Now, there's a weird thing happens. I've got lag on my camera and it's upside down. So this is going to be really interesting. This, as a deck of playing cards, I've literally just opened it. So what you can see here is that the cards are in order. And if I deal them out one at a time, you find that you've got the spades first, ace, 2, 3, 4, 5, 6, 7, 8. They're very slippy, so they'll slide around 9, 10, jack, queen, king. And that's in poker, that would be called a straight. You have cards which are in sequence. So normally, of course, in poker, you only have 5 cards, or you have to choose 5 cards out of those that you have. So this would be a straight, but this is an unusual straight because it's a straight of 13 cards. If I deal my next set of cards, which are diamonds, on top of those, 5, 6, 7, 8, 9, 10, Jack, Queen, King, then you can see one of everything. And if I deal the next ones, and I'm not dealing these in order, I'm dealing them sort of haphazardly around, once again, you can see one of everything, ace through king. And if I do it again, then you'd see one of everything, ace through king. And that's no surprise that when I deal it like this, I get one of everything on top and showing. Okay, but that's if I do that. Let's just throw those to one side. I'll deal with those again later. Here, I've got a deck of playing cards which are in a random order. Now, again, as Joe was just saying, this is sort of TV production. You don't know that for sure. If you were watching Kevin Houston earlier, he did a perfect shuffle and returned the cards to their original ordering by doing 8 consecutive perfect shuffles. I'm not going to do that. This is haphazard. These shuffles are definitely not perfect. The cards are effectively random ordered. But if you try this for yourself, then you'll know that there is no trickery. And if I put these in 13 piles of 4, pile of 4, pile of 4, pile of 4, and I keep doing this, then now it's very unlikely that I'm going to get one of everything on the top. You can calculate the probability. I'm not going to do that, but you can calculate the probability, and the chance of having all the top cards different is vanishingly small. It won't happen in the heat death of the universe. And you can see here it definitely hasn't happened because I've got repeated 5s, I have repeated 7s, I have repeated 10s, I have repeated 4s, I have repeated 8s. There's lots of repeats. So there must be some missing. I can't see a 2. I've got a 3, 4, 5, 6, 7, 8. I haven't got a 9. I haven't got Jack, Queen, or King. So the challenge now is this. With the cards dealt randomly, if I'm allowed to choose which card is on top, can I make the top cards all different? What do you think, Katie?
Oh, I'm not too sure. I'm excited. I'm excited to see, though.
Well, there's 52 factorial possible orderings of a deck of playing cards. That is just an unbelievably large number. So you might think sometimes we can do it, sometimes we can't. Let's have a try with this. I've got duplicate 10s here. So let's, oh, and there's a queen. And I don't have any queens anywhere else. So instead of using this 10, let's use that 10, and let's change this to being a queen.
Swap out for a queen.
Right. So I've deduplicated my 10s and I have a queen. What about this one? Well, actually, I've got duplicate 8, so I can use that 8. And here, well, I'm missing both 2 and 9. What am I going to choose? Let's choose the 9. So I've deduplicated my 8s and I have a 9. I'm still missing a 2. What about in here? Well, that doesn't help. I can already see a 3 and I can already see a queen. What about in here? Well, that doesn't help because, okay, so deduplicating these doesn't help at all. Well, let's use this 4 because I've seen peeking out from underneath this 4, I've seen a king. So now I've deduplicated, I've got 2 4s now. What can I do with this one? I'm still missing a jack, so let's use that jack. And I can keep playing this game. Let's see, I've got ace, I'm still missing a 2. I've got 3, 4, 4, 5, 6, 7, 8, 9, Jack, Queen, King. Okay, so what did I say I'm missing? Missing a 2.
Yep, still no 2.
What have I got duplicated? I've got 7s duplicated. Is there a 2 in here? No. Is there a 2 in here? No. Maybe I'm stuck. Well, if I can find, there's a 2 here and I saw a Jack here. No.
Yeah, we had the 2 earlier. Yeah.
Yeah. Hang on, I've got a Jack here, so I can use this Jack instead of this 7. And now instead of this jack, I can use this 2. Have I succeeded? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and I've got it.
Amazing.
I've managed to do it. Now, here comes the fun bit. What I'm going to do is I'm going to skim the top card off all of these piles. So take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now instead of having 13 piles of 4, I've got 13 piles of 3. And the question is, can I do it again?
Okay, so you've reduced the number of cards in each pile down to 3 cards. So there's fewer choices underneath these top ones.
So there's less flexibility now.
Yeah.
But there's perhaps the challenge itself is smaller. So maybe you can have a trade-off there. And in fact, here I can see I'm missing a 2, but I've got 3, 4, 5, 6, 7. I've got duplicate 8. I'm missing a 9, and I've got jack and a duplicate queen and a king. I'm not missing many. I'm missing a 2 and a 9.
So starting from an easier place.
Yeah, but I've got, here we go. Here's a 2 underneath my duplicate 8. So I can use that. So that's got rid of that duplication. It's given me a card I want, and I can see a 9 peeking out from under that queen. So that one has turned out to be much easier. I have no idea how easy or hard each of these will be because the ordering is random. And when you random order the cards, you've never seen that ordering before, ever in the universe. So let's skim off. Have I done it now? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So Perfect. Let's skim the top card off again. And see how this. I don't know how well synchronized my voice and the video is. So that's
pretty well synchronized. We've got it so that your cards are the only things that people can see.
Right. Okay. So again, I've got every card there, and now I've got 13 piles with only 2 in each pile. Can we do it again?
Getting into the swing of it now. What
2
have we got?
2s. I don't have a 3. I've got 4, 5, 6. I don't have a 7, but I've got 2 2s. So let's just use that 7. So ace, 2, still missing a 3, 4, 5, 6, 7, 8, 9, 10. Oh, no jack. Oh, there's a jack underneath that queen. I've got duplicate queen, so that's worked.
Perfect.
What am I missing? Still missing a 3. What have I got duplicated? Duplicate. Now, underneath this 8 is a 9, and underneath this 8 is a 4. But if I use this 9, then I can swap that 9 for the 3.
And then we've got
I think we're done again.
Yep, looks like it.
Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So let's take those off in order. Ace, 2, 3, 4. You need to be very careful. I'm about to pick up a 5, and you might accidentally pick up that 5. You need to remember to pick up that 5.
It takes quite a lot of quick thinking on your part, this one, because as you say, each time you're seeing it, it's a completely new set of cards.
A completely new set of cards.
For you to think through.
No, absolutely. But I have done this before. I've cheated. I have done this before. So there's my straight. So once again, I've chosen a straight, picking 1 from each pile. And we get the last one for free.
Yep.
Unless something's gone horribly wrong, I get the last one for free.
This will be the point that you find out that something's gone horribly wrong, isn't it? If this
exactly
doesn't work out.
But you can see here I've got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Now, I don't remember where these ones came from, but imagine I put them back. Imagine I put them back exactly where they came from. I don't know where it was, so pretend it's like this.
Okay.
And then with the previous one, so this is the previous straight, that's still randomly sorted because I picked them off randomly. Let's put those back in some order. So what I'm doing now is I'm putting the cards back.
like rewinding time, we're imagining.
Yeah. And let's pretend I really am rewinding and putting them back exactly where they were originally, which I'm not, but let's pretend I am. You could, in theory, do this. Now, again, the top layer are all different because that's what I've just put back. The second layer are all different because that's what I've just put back. The next layer. So in fact, with this random ordering of the cards in 13 piles of 4, I have reordered each pile, this one and this one and this one and this one, so that I have 4 slices, and each slice has one of every rank.
Yep.
I've succeeded. How often do you think I would succeed in doing that? And that's the question. It's not just can you do it, because sometimes maybe you can, sometimes maybe you can't. So here we go. These cards are just sort of randomly picked up and they're kind of randomly shuffled again. And if I do this just the once more, so I'll just give them a quick riffle there. And I'm going to put 13 piles of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So am I cheating, or am I doing some kind of fraud? Am I being a magician? Am I forcing something on you? Well, you can test this for yourself. Or does it always work, or were we lucky? So those are the questions. Now, I can tell you I'm not cheating, but you don't have to trust me. I strongly recommend you don't trust me. If you take one thing away from this entire presentation, it's never trust Colin. That's
never trust Colin.
Right? Never trust Colin. Right? So always never take it on faith, because the wonderful thing about mathematics is it may take you time, but you can always check it for yourself. It may take a lot of time, but you can always check it for yourself. Let's just do one layer here and see if we can get it to work. I've got duplicate 9s, duplicate 6s, duplicate 8s, but I've got ace, 2, 3, 4, 5, 6, no 7s. Well, I've got duplicate aces. Let's see if I can get a 7 out of that. No. Oh, but I can get a jack, and I've noticed that a jack is missing. So from this one, I can get a jack. That's deduplicated that. I'm still missing the 7. Where might I find a 7? Do I find a... Yeah, there's a 7. And that's deduplicated the 9s. Sometimes people find it easier to go, well, there's an ace. Let's put the pile of 2s next to that. Let's put the pile of 3s
so like
next to that.
It.
Yeah, some people, you're allowed to move the piles, but you're not allowed to move cards between piles.
So as long as you move the pile as a whole, that's
as a whole, right? So 4, 5.
I'm having a look at the chat. There's a few people that were saying that they started thinking that it would never work, and now they're thinking it might always work.
Right, cool.
And then there's a few people questioning whether it always work. Yeah. And a lot of people saying that they too will now never trust Colin.
Oh, perfect. Absolutely perfect.
You might have ruined lives for Collins all across the globe.
Yeah, well, maybe trust a different Colin, but never trust this one.
Not this Colin. Okay.
Not this Colin. Not this Colin. But this is the wonderful thing. Now, if I try it again and it happens to work again, maybe that's just chat, but it hasn't worked so far. But I'm missing a 10 and a queen, and this is a duplicate. But I've got a queen in that duplicate, so I can use that one. So I've got duplicate 6s, and I'm missing a 10. If there's a 10 in here, no. If there's a 10 in here, no. Okay. Where are my 10s?
I have to go hunting.
Well, there's a 10 there. So I could use that 10. Piles. Yeah, if I use that 10, I would need to find a 4 in one of these to replace it. Is there a 4? No, there's no 4 in there. Is there a 4? No, there's no 4 in there. Where's another 10? Is there a 10 in here? No. 10 in here? Yeah, there's a 10 in here. Is there a 2 in here? No. Is there a 2 in here? No. This is proving really tough. It's a tricky one, isn't it? Maybe it's not going to work. Who knows? I mean, let's just pick another 10 at random. Is there a 10 in here? No. Is there a 10 in here? No.
Moving the piles like this seems a really good way for people who are starting it for the first time or giving it a go.
So here we go. I found a 10 here. I can put that there, but now I'm missing a jack. And now I'm missing a king. Sorry, now I'm missing, still missing a jack. Let's use the 7 from that pile. I'm just doing this randomly now. Is there a jack in here? No, there isn't. Let's use the ace instead and use this one here. Is there a jack in here? No, there isn't. Let's use an 8 instead. Yeah, maybe this will cycle around forever. I don't know.
So it might take it might have to work through quite a few piles, because it seems like last time we got to it quite quickly, didn't it? But this is showing that that's not always the case.
Absolutely. And this is just showing that, maybe, look, there's a jack there. Let's use that jack. Now I'm missing a queen. Where's a queen? There's a queen there. There's a queen. There's a queen there. Let's use that queen. Just moving them randomly around. Sort of a real test
of memory for you as well, where you saw.
I'm missing a 3. I'm still missing a 3. I've got duplicate 5s. Let's use this 5 instead of that 5. I'm missing a 3. Can I find a 3? There's a 3 there. That doesn't help. There's a 3. Oh gosh, maybe that doesn't work. Who knows? Probably in the chat, people are screaming, I found it.
I'd love to see what people think in the chat as well.
I'll use this queen instead of this queen, because in this queen, I can find a 3.
Fantastic. Oh, you can't see me, but give me a round of applause.
So I've got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. It has worked this time. So does it work every time? Does it not work every time? Have I just been lucky? You can see there that sometimes it can be quite tricky to be able to do this if you can do it at all. So there's the question for people in the chat, and to go away and try it for yourself. And if you find that it always works for you, get somebody else to try it. Torture other people. It's a great way. You've heard of icebreakers at parties. This is a great way to form the ice at parties. It will freeze people out. It's a great one. So that's the challenge. And then the question is, if you find that it always works, can you prove it? Can you find a way to prove that it always works?
There's some people suggesting in the chat about a few ideas of how to go about it as well, how to go about proving it as well. And still a lot of uncertainty about whether it does always work. Or not.
It's a great challenge. Now, the interesting thing is, well, I say it's interesting, that lets you calibrate my concept of interesting. This is 13 piles of 4, but what I can do instead, if I gather these up again, and of course this is mixing them up randomly again, instead of having 13 piles of 4 and trying to get all of the top cards a different rank, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I get the last one for free. I have duplicate suits. Can I make all of the suits different?
Okay, so this is a variation on what we were doing before. So doing it with suits rather than the numbers.
Now I'm missing a club. So let's just find any old club in here. There aren't any. Isn't that amazing?
That is amazing.
There are no clubs in there. All right, let's use this one instead. We're on a winner here. All right, so let's use that as the club. Okay. So now I've made all of the suits different. So what I'm going to do is I'm going to put that upside down under here. I'm going to put that upside down under here. I'm not allowed to touch the cards that are upside down. So now I know that upside down, I have a slice of cards that are all different suits.
Yep, we've got that slice again.
Now let's do this again. I've got duplicate diamonds, so let's pick a club from that one instead. Let's pick a heart from this one instead. All the suits are different, so let's put them upside down underneath, upside down underneath, upside down underneath. So you can see now I have inverted, I've swapped over the roles of rank versus suit. So instead of 13 piles with 4, I've got 4 piles with 13, and I want to make the suits different. And if this succeeds, I will end up with 4 piles, with each slice having a different suit, all 4 suits appearing. Is that always going to be possible? If one, surely the other. But that's a challenge for people who are interested.
And it'll be interesting to see whether people who work through the proving the other one, whether they approach it the same way for this one, and how they get on with it. Having a look in the chat, it's really good to see that there's people that have been trying it along with us. So Smokey Furby said tried it again, so the first layer's gone okay for them.
Okay, cool.
Be interested to see how they're getting on as well.
Brilliant.
That is us coming to the end of our time. We've only got about 4 minutes left. Did you have a quick treat for us as well as a trick?
I have, very quickly. Now I'm going to have to do this close up with my hands.
Okay.
So I have 2 corks here. This one is labeled left on both ends. It's labeled left. This one is labeled right.
Okay.
And what I'm going to do is I'm going to put them in my incorrect hands. I'm going to put the one marked right in my left hand.
Okay.
And the one marked left in my right hand. And what I want to do is I want to have the cork between my fingers like this in the correct hand. I want to do it with that one, and I want to do it with this one, and I want to do it at the same time. If I try that, there's a problem because they end up being linked. You can see that they're linked there. And if you try that, you'll find that they end up being linked. Even if you turn your hands all the way over, they end up, I can't do that under the camera. You'll find that if you want to put that one in that hand and that one in that hand, they end up always being linked. So I'd like to do that. What I'd really like to do is to take them out at the same time without them being linked. But the problem is that doing that seems to be impossible, even though you just saw me do it.
Ooh.
And I can put them back again.
Oh, amazing.
And they really are swapping over. They really are changing hands.
Not just camera trickery.
Not just camera trickery. And so that is your little treater challenge.
Fantastic. So if people want to have a go of that, they can go away and try it. And if we wanted to see more of the kind of things that you get up to, where can people go to find out more about what you do, Colin?
Well, there's my website, which is this one.
Fantastic.
You can always send me an email, which is this one. I get a lot of email, but I do try and reply to every email that I receive. And if you send me email then and ask where I'm going to be, I mean, obviously at the moment the answer is at home. But if you visit my website and have a wander around in my website, then it's perfectly possible that you can come and find me. I'm going to put my video back on.
I was going to say, it would be nice to see you for these last couple of minutes.
I can't do that because you've stopped me. You need to restart my video.
I think there's someone in the background will be able to turn on Colin's
Here we
video.
go. Start my video. There we go.
See him to say goodbye. Oh, there we go.
Okay, there we are. So
well, that was absolutely brilliant, and we've got your website and your email there, and
super.
I think we'll post that in the chat as well. I am definitely going to go away and try the card trick with my friends as well. So
it's really fun.
I'm really interested to see.
It's absolutely mystifying as to why it always works. There is a secret as to how we can prove one way or the other. I'm not going to tell you whether it always works or not.
It sounds like something that's going to require a little bit of what we spoke about at the beginning of working your way through it for a little while until you finally have that moment, that fantastic moment in maths where you figure it out. Well, thank you so much for your time.
Absolute
that was
pleasure.
Absolutely brilliant. And it was really, really lovely to meet you.
Nice to meet you. And I'll see you again, no doubt. Take care.
Absolutely. Bye.
Bye-bye.